you're ready, off you go.
Yeah,
Oh, well,
this space-like computations on.
Sorry, Mike. Have you shared your screen?
I thought I had.
Okay, not yet.
I'm not muted, and you should be getting me.
Yeah, we can hear you. I haven't muted anybody yet, but if you can just share your screen. There we are.
Okay.
Okay, so now, of course, whenever that happens, I lose the mute button, so I'm going to do it now. Okay, so Mike, I'm going to mute everybody, so if you unmute yourself now. Okay. So you need to unmute. I'll
There we go.
Lovely. Okay.
All right.
Okay, we're ready to go.
Space-like computations on computing machines is the title of a patent that I applied for about 5 years ago, which I can now talk about because I couldn't talk about it before the patent was granted. The abstract you're seeing below is a very shortened version of the abstract of the paper itself, which is called Out of the Box Self-Organizing Awareness. Anyway, this is just the abbreviated abstract. And if you want to see the whole paper, then you can get it from rootsofunity.org. Or if you got the email for this conference, and it's in that email too, you have the link. What follows now is the elevator pitch, if you will, that I wrote for pitching this patent. And so I'll just read that up for you. The invention targets the construction of logically distributed computational systems and solve this widely researched but hitherto unsolved problem. This is a problem of, in computer science, we can't do anthills, we can't do ecosystems, we can't do anything. It involves a system that seems to have its own coherence. We don't know how to do that until now in computer science. And the way I did this was to implement the universal wave function of quantum mechanics in what I call computer code, not to be too specific. And the key to this is the concept of co-occurrence of events. And I will be doing the coin demo, so you can all sit and relax now a little later. But the idea is that co-occurring event contains information that cannot be accessed sequentially. With this, we step outside of everything you know about theoretical computer science and Alan Turing's theorems. This same approach, this universal wave function thing, it also turns out to be an efficient self-organizing paradigm. And I am not in any doubt that at some modest level of complexity, it will undeniably be aware, and you will be able to know this. So, for starters, there's no numerical computation whatsoever. And that's because the so-called data in this system is the patterns of synchronization, who came before and after it at the same time as other events. And there's no physics. It's pure combinatorics. It's inevitable, the structure you see. I haven't put anything in by hand. And yet the system semantics do satisfy U1 cross SU2 cross SU3, which is the standard model of quantum mechanics. And then I get to add the special orthogonal group in 4 dimensions, which gets us to a full theory, including gravity, as you will see in a later. But I don't talk much about physics. When I talk about physics here, I'm just using it as examples, using concepts and examples that you probably run across if you've been following everything going on in physics. So the actual runtime structure that produces all this behavior is built entirely out of synchronization tokens. And to understand what a synchronization token is, I can tell the story of a train up in northern Scotland. This is a true story I was told by a Scottish programmer. There was an off the main road town, and a single track went up to this town. And to make sure that trains would not collide as they went back and forth on this single track, there was a stick at the intersection. They would pick up the stick when they went up the railroad track, the spur, and then they would put the stick back in the bucket at the intersection when they came back. And that's a good example of what a synchronization token is. If you arrived at the intersection and there was no stick there, then you had to wait. If you didn't wait, then you'd run into the other train. It'd be a terrible thing. So that's what you think of the tokens as sticks, like the trains used in Scotland. Now, as far as what would you use this for, it's like asking what is a computer for, what is a baby for. But right off, you can see at the Internet of Things, which we're talking traffic systems and factories and apartment buildings, large buildings, anything where you have to coordinate a lot of disparate activity, and you don't want to program it because you can never, there's no end to programming this kind of thing. So having a system which is adaptive and learning the job and staying on top of all kinds of new developments, that's what you want. Then the whole Bitcoin thing, it works because you have to do a lot of computation to keep the system self-consistent and honest. But basically, when you think about funds transfer, what it basically is moving something from A to B under mutual exclusion. And that's what this hierarchy is all about. So in my view, things like Bitcoin are a no-brain application of this technology. And presuming I'm right about awareness and everything else, well, then this patent will be the foundation of all computing and a lot more because it cuts very deeply. Now, since I'm talking about awareness here and consciousness, I think I should define it. This is a definition that I'm willing to defend to the death. Awareness is a complex, adaptive, self-preserving resonance. So it's a wave-like thing. Awareness is of a wave-like character. That's its basic character. When you fall asleep, the resonance changes. When you wake up, a different resonance is, your waking resonance is established. And depending on what kind of resonance it is, you can be in one or another frame of mind. What I call a 4-tier, and I'll explain that a little later, one of these 4 tiers is enough. Sort of one chunk of hierarchy is enough. Consciousness, to get awareness. Consciousness is awareness of awareness, and you need 4 of these chunks. And then because they are adaptive and learning, the frequencies and amplitudes of their resonance, which come from the surround, they will determine via learning what kind of awareness or consciousness you get out of that environmental experience. So the vehicle for doing all this is geometric algebra, Clifford algebra. It's a multi-dimensional algebra, which means that you have lots of one-dimensional vectors and they're all mutually perpendicular. It's a graded algebra, which means that not only do you have vectors which look like little arrows, but you can have planed like AB, volume ABC, a 4-dimensional volume ABCD, and so on. And these are all mutually perpendicular. So the algebra itself, every term in the algebra is perpendicular to every other term in the algebra. And that means that it's what's called coordinate free, which means that the algebra supplies its own coordinate system. You don't have to go outside. You don't have to wheel in a matrix, for example, with some ordering on the rows to define your coordinate system. The algebra is its own coordinate system. And that means from a computer science point of view that you have the whole world at your fingertips. There are not other things that you have to sort of pay attention to or be aware of without any explicit appearance in the code. And so it's a vector algebra, which means that every item in the algebra has both a magnitude and some sort of direction or orientation. The multiplication in this algebra, when you multiply 2 things together, what you do is rotate the one 90 degrees relative to the other. So multiplication is 90-degree rotation. The algebra is non-commutative, which means that AB is minus BA, And what that really means is that A and B are perpendicular to each other. And that's why this is called a geometric algebra, because this basic multiplication is talking about perpendicularity, and everything happens in the algebra should be thought of as being geometric, unless explicitly otherwise. The algebra is over Z3, 0, 1, and minus 1. This is my expansion. I imagine in the press, if this ever gets written up, they'll talk about the big move was to go from base 2 to base 3, but that's not really it, because everything's really happening still in a two-valued base, 1 and minus 1, whereas 0 is not a number, 0 is void. And you can't have a serious theory of everything if you don't have void. Void is, of course, the absence of all properties, including the absence of all properties. That's what void is. It's the ultimate no thing. So we're basically doing binary type stuff with 1 and minus 1. And the reason I did that is because I knew I wanted to go to a vector algebra. And if you have a vector algebra, then you have to have a minus 1. And so that was the reason for the expansion. I wanted to use a physics type mathematics. I never liked automata. So the faster I could get to a physics type mathematics and expand the semantic world of computing, the better I liked it. So here's an example of, these are the kinds of things that are in the algebra. Each of these are, as I say, vectors, arrows. This is a plane. This is a volume. This is a four-dimensional volume. A key development in my understanding of all this was a thing called Parseval's identity, which dates from 1799, after Parseval got out of the Bastille. And it's a generalization of the Pythagorean theorem to n dimensions. And it says that if you have an n-dimensional function, think of this as the environment. If you have an n-dimensional function and that environment is being projected onto this vector space that we have here, that projection of that function onto this n-dimensional vector space is the Fourier decomposition of f. That means that if you think of this n-dimensional function, its value is the point of the arrow, this multi-dimensional arrow. That's the value of the function at that point. And we're in n dimensions, think of Pythagorean theorem, but a whole multi-dimensional world of right triangles. And that hypotenuse has a piece on every one of those perpendicular parts. And those pieces are the Fourier decomposition of f, because each one of these things is an oscillator. So that's how it is that if you think about in a right triangle, you can think of it in terms of the sides, in terms of sines and cosines, and you can also think of it in terms of a and b, the lengths of the sides. So there's a duality in the Pythagorean theorem and the idea of a right triangle. You can either think of it in terms of sines and cosines, as say waves, or in terms of lengths of vectors. And so in a sense, that's where wave-particle duality begins as well. Anyway, whenever I'm talking from now on in terms of this hierarchy and all this stuff that's going on, you should be thinking it's waves, okay? It's waves, all of it. The phases in this phase space are the phases of the synchronization, before and after. Can you go now? Can you not go now? Signal and wait, as we call it. And when we look at the code, you'll see some tuples, and those tuples are the tokens, the synchronization tokens. That's when we look at the code later on, you'll see what I'm talking about. Okay. Space is a big thing here, and there's no place like space. So the idea here is we're going to work on quaternions, which are an alternative way to describe 3D, discovered by Hamilton in the early 1800s. And they have the property that the product of any two of them gives the third, and it's a circular product. So x, y, y, z, z, x also gives, each one of those products gives the missing third one. And the reverse is the negative. And what this really is saying is that the entire coordinate system has a handedness. It's either a left-handed coordinate system or a right-handed coordinate system. There's two coordinate systems. They're equivalent, but they have a handedness to them. That's what this is saying here. So it turns out that we get for free in the algebra 3 different versions of quaternions. The first one is Hamilton's, and it's 3 planes, A, B. Think of the 3 vectors A, B, and C. They can form three planes, AB, BC, and CA. And you can think of then finding a coordinate in this as turning 90-degree dials until you isolate a point in 3 space by turning the 3 dials to the 90-degree position. And if you then take our top element there in the algebra over ABC, then and rotate our quaternion triple, there's these 3 planes, each perpendicular to each other. We rotate that in a 3D rotation. What do we get but the 3 vectors, which in this algebra also indicate a photon. So you can see the intimate connection between photons and space. They're 2 sides of the same coin, really. So that's the classic version of quaternions. The next version of quaternions I stumbled across in my wanderings using Doug's calculator. And it turns out that if you go to 4, there are 4 possible vectors. You take them 2 at a time, that gives 6. 4 things taken at 2 times gives you 6. So you got AB and BC and CD and AD and BD and so on. You got 6 of them. It turns out you can combine them in pairs and also get quaternions. In other words, this is one of the quaternion pairs. This is the next one. This is the third one. And if you multiply them like this, they behave right, and they have this same property. So it's exactly the same thing as a quaternion. If you do the multiplication table, it has exactly the same form. It's just that it's a more complicated version of the same thing. It's 2 mutually orthogonal planes, but together in concert, they act like regular quaternions, and they produce a 3D space. Also, it turns out that if you add all 3 of them, you take these 6-element vector, A, B, B, C, C, D, all these, you take these 3, add them together, and you square, you get 0. And that's, of course, the footprint of a nilpotent boson. And we identified this because it is demarcating a 3D space. We identified this with the Higgs boson. And this gives us these special orthogonal group in 4 dimensions. There's a theorem that says that there's a group spin 6. And our 6 elements here, they are an element of spin 6. And in that case, it maps to SO4. The other thing that spin 6 can map to is SU3. And as we get that, it turns out there's one more thing like the Tauquirnions, and I call them Tauquinians. Let me just say a word about the names. Tauquinian is a Spoonerism on quaternion. So I interchange the Q and the T to get Tauquirnian instead of quaternion. So that the Tauquirnians are the 4-dimensional gizmos, and they're at the base of gravity, as we'll see. Whereas the Tauquinians, it turns out they're SU3, and that's electromagnetism. And they're just like the Tauquirnians. They come in pairs, and they act just like quaternions, except that they're 5-dimensional gizmos, a plane and a volume. And SU3 houses electromagnetism. Okay, so this hierarchy I keep talking about, where does it come from? Well, the boundary is what I call sensors. When I start talking code, I think of these vectors on the boundary as sensors. 1-bit sensors, they go between 1 and -1. +1 means whatever it senses is present in the surround. -1 means whatever it senses is not present in the surround. It's just a presence or absence, that's it. And as an implementer, you have complete freedom to assign whatever you like to these things. And so we're going to have a bunch of these things, and we're going to put them together somehow. And this has been the stumbling block, hierarchically speaking, in computer science, because when you get right down to it, the only real hierarchy in computer science is function composition. And that turns out to, as we can see in the state of software today, it's a completely unusable hierarchy concept, but that's the only one we have until now. So where do these, in a computer science computing sense, where do these 2 and 3 to 4 and 5-dimensional things come from? Well, for starters, maybe your intuition will let you see that if I have A and B and they're doing their thing, somehow, since everybody's perpendicular and A and B are perpendicular, I can think of it, A and B and rotating A and B through these various states. That doesn't quite get me in a more mathematical sense to AB. So, but just to make the initial point, this gizmo, this small delta, is called the co-boundary operator. It is the geometric version of integration from the calculus. So this hierarchy that we're building is the calculus hierarchy. It's not a function composition hierarchy at all. Anyway, to do the hierarchy, you gotta do a little demonstration, which I forgot to quite prepare for here. Luke Hoffman, last time I gave this talk, which was some years ago, he shamed me into using some coins that you could see. So the point of this, we're talking here now about co-exclusion. What I'm claiming is that if you see something at A and not at B, or something at not at A but at B, you can conclude that AB is in the picture. And AB, of course, is a rotator. It rotates 90 degrees every time. So I show you a coin, and the point of this demonstration is to convince you that there is something in the world that a Turing machine cannot do, something that cannot be done sequentially. So I show you this coin, and I guarantee you that this is an ordinary coin, which I've made myself out of tinfoil. Okay, here's this coin. Now I'm going to show you another coin. This coin, I will stipulate, is exactly identical in every relevant respect to the first coin I showed you. And now I'm going to ask you a question. My question is, how many coins do I have? The coins are indistinguishable, but you know there's at least one because you've seen it. Now, if I have two coins, then I don't have one coin. If I have one coin, I don't have two coins. So the two possibilities are mutually exclusive. And if they're mutually exclusive, it's either one or the other. And that is the definition of a bit of information. So in the indistinguishability of these coins lies some information, if I can just get at it, but I can't get at it sequentially. So that is to say, when you get the answer to the question, how many coins do I have, you will have received one bit of information, all right? Okay. You now see that I have two coins. So you've received one bit of information. And now I ask, where did that bit come from? It came from the fact that you saw them simultaneously at the same time. Now, of course, this word simultaneous is a whistle, a dog whistle to the computer, to the physicists, saying, well, Einstein banished simultaneity from the world. That is true, but only in 3+1D. All right, and we're not in 3+1D here. All right, we're in this multi-dimensional wave function space. We're not in 3D space. So and there's no time in this space, by the way. That's why it's called space-like. And so when you see two coins, you can see them simultaneously, and you received one bit of information because you saw them simultaneously. And furthermore, if you see this simultaneously, then before they were simultaneously, they were not there. So you have this situation. I had them both, I had neither, or I have one, or I have the other, but not both. In either case, I have all four cases on the circle, the four 90-degree quadrants, and so I can conclude that AB is a valid operator, and that's something I have learned. AB is basically what I learned about the relationship between having a coin here, having a coin there, and so on. The co-exclusion comes from the fact that I show you this, and then I show you this. Now, in this case, this excludes this, and this excludes this, so this excludes that. And that's the co-exclusion inference that allows me to conclude. Now, in calculus, that's just an integration, okay? And the co-boundary is, I claim, the source of anytime you see emergent behavior, and it's really emergent, then it's because this is what's going on. And just for completeness, then, if you're going to have integration, you need differentiation. Of course, this is where the whole story starts. And so the boundary operator uses the same symbol as the differentiation symbol, partial differentiation, and is defined as an eigenform. So if the boundary of the entity Q with respect to this guy x plus y is going to be x prime plus y prime. So when Q operates on this guy here, you get this guy back with a few dents, and that's the eigenform. So after every transformation, you get kind of the same thing back. And really what these are like the various facets of Q that you're getting in this way. So that's how we get our first level of hierarchy. There's our first level of hierarchy over our one-dimensional vector. So we're up to 2 dimensions now. And so now that we know the principle here, we can just do that again. We look at the guy we just learned, and then a third thing, say, well, those two, if they co-exclude, then we get to conclude ABC, and that's also an atom, if you will. It's unitary, and this is the atom of charge, whereas the 2D guy, that's basic spin. That's your basic spin. This is where spin comes from, because it's expressing the idea of mutual exclusion of processes. So that's how you get to the second level, and we can do that again. This time, well, instead of 1 plus 1 or 1 plus 2, we'll do 2 plus 2. Notice the combinatorial aspect here, and that's co-boundaries A, B, C, D, and this is actually the unit of space and mass. And this is the thing. If you go back to the Tauquirnians, the Higgs form, there's 6 entities. That's 2 to the 6, 64 possible forms of the Higgs boson. And if I remember my history right, 60 of those square to a scalar. They square to 1, and the other 48 square to 0. So the Higgs, what I'm calling the Higgs, contains both mass and nilpotent space. So that's where things come from. But they're also, as you can see, made out of space. Anyway, the important thing about ABC, this guy here, is that it's irreversible. So this is a thermodynamic element in the wave function. And that's our third level we built. We can build another level yet. So here was 1 plus 1, 1 plus 2, 2 plus 2. Now we got 2 plus 3. And the same thing. And once again, here's our Tauquinian. This is a Tauquinian. This is a Tauquinian. And it's also irreversible. And just for completeness, here's 1 plus 3 instead of, so we got 1 plus 2, 1 plus 1, 1 plus 2, 1 plus 3, 2 plus 2, 2 plus 3. So we have them all as a point. We have all the singletons up to 5, A, B, C, D, E. We have all their products, A, B, A, B, A, D, C, and so on. And we have all the pairs, 1 plus 1, 1 plus 2, and so on up to 3 plus 3. They're all there. And that's all we're going to use. That's all we need. Now, just as an interjection, the Tauquirnians and the Tauquinians are also entanglement operators. And the example of that, which is easy to understand, here is two things, a co-occurrence A and B, and co-occurrence C and D. And if they interact, those co-occurrences, then we get these 4 spinners, and they have a particular sign relationship to it. These are, oh, I can see this should have been BD here. I apologize for that. A, B, A, C, A, D, B, C, B. There should be a BD there. So you notice there's 4 of them, and they have this particular configuration. But if we operate on them with our Tauquirnian, which is this space-like, but also entangling operator, notice what happens. We lose half of the phases. They're gone. And there's no way we can get from here back to where we were. So that's why it is irreversible. And that's something that Doug found in his thesis that we scratched our heads over. So anyway, the entanglement looks like this. We have this co-occurrence here, we have this co-occurrence here, and before they were separate, we had AC and AD, there they are. You know, we could refactor it back out to this form. But after the entanglement, we can't factor this back to the product of 2 sums, and that's called non-separability in physics, and there you see the entanglement right in front of your eyes. And the irreversibility is the loss of this phase information. So the algebra is pseudoscalars. They're these guys here, the basic elements of the algebra. If you square them just for fun, then you'll get this sequence plus, minus, minus, plus, plus, minus, minus. And those who have been around the block a few times will recognize this sequence as the powers, the signs of the powers of the square root of -1. So we are neck deep in imaginary elements here. So notice though that the semantics therefore actually repeat every 4. It would go minus, plus, minus, minus, plus, plus, minus, minus, plus, and so on. And the message for me as a computer scientist, well, say, hey, we can just collapse the entire semantics of the algebra into these 4 gizmos, these 4 levels at the same time. This is what I call a 4-tier, a tier made of 4 elements. And this is what it looks like. Here's a 1 plus 1. There's the first level we make, and then the second, 1 plus 2. And then we can do this, but we're not going to do this here just because we're going to do the evens. So we have 1 plus 2, 2 plus 2, and now we're past 4. So what do? Well, we're just going to map that up to the next level and say, well, when we get to 4, that's A, B, C, D. What we're going to map to 1 is the orientation of A, B, C, D. Just like the spinner has an orientation, the charge has an orientation. Well, there's also an orientation A, B, C, D. We'll map that to a one vector at the next level. So the ones that are mod 4, 0 mod 4, they turn into 1-bit sensors at the next level. And also 2 plus 3, which is in the electrical end of things, that mod 4 gives us a 1 as well. So the boundary layer of the second tier is the 1 vectors coming in part from 2 plus 3 down below and in part from 2 plus 2 mass-like, space-like things. So that's the new boundaries up there. And then finally we have 3 plus 3, which is 2 mod 4. And that says that when this hierarchy is growing, the way it inches itself out into the world, into the next level of organization, is it has its fingers, this magnetic field sort of reaching out into, it doesn't know where this is going to go. But and if you think of a biological situation, you can, this is like the fuzz at the edge of the gizmo of the cell or whatever it is that is trying to interact with the rest of the world. That's the interaction impulse, if you will, and motivation. So we build 1 tier, and then as that is topping out, it forms the basis of the next tier, and we can keep going like this. And that's the way we're going to write the code for this. We're going to write all the code that'll do 1 tier, and then we're just going to stack them on top of each other. And that's the growth. And of course, this is all wavy. This is all wave world, remember? So this is all, think of what's going on in here as resonances relative to what comes in from the boundary. So what do we have? From at the lowest level, we have the circle group, then we have the quaternions, then we have the Tauquinians, and then we have the Tauquinians. So we have basically the circle, basic wave situation with the circle group. Quaternions give us, the classic quaternions give us classic 3D within the wave function. So we got a 3D, if something is coming down, the control structure of this is you bubble up through the levels and then trickle back down. And so the quaternion rotation is the last thing that's going to happen before it goes out the door. So whereas the next level up, that's going to take care of the charge situation and finally the space-like situation. So we go wave, 3D, 3D, 3D. And the last 2 are entanglement operators. So everything in here is geometric, everything. So looking at this from a little farther away, we have existence, magnetism, electricity, and then mass and gravity. And they're just pointing out that Newton, when he was formulating his theory, he wasn't sure what to call gravity, so he was thinking about calling it amor, which is Latin for love, which considering Newton's personality, his make you wonder how he even noticed it, but there you have it. I will also just point out, I'm not going to explore this kind of thing in this talk, but this is exactly the structure of the chakra system in meditative technology. So you can see where it's going to go in that respect. Anyway, going back to this hierarchical situation, we can see then that the way this works, the way the wave function works is it inherently factors the inputs at the boundary into these 4 categories. You can't help it. It's inevitable, and it covers everything that could happen in terms of the combinatorics. So you have these stackable tiers. It gives you a constructive hierarchy. It's discrete. It comes in lumps. It's finite, but unbounded. It's non-reductionistic. It's non-deterministic in terms of what its behavior, and it's non-material. It's non-material because everything is geometric. Let me just mention this unbounded thing. I think most people here, if you're not computer science, you hardly know anything about this synchronization business. In computer science, there's sort of 2 worlds. There's the world of people who write algorithms, then the world of people who do operating systems and networks. And in the algorithm end of things, everything is according to Alan Turing. And there's all these theorems. But if you use Alan Turing's automata-based semantics, then a synchronization network is a finite state machine. And a finite state machine is not nearly as sexy as what's it called, a full Turing machine. But what was overlooked in this, and so therefore you didn't have to worry about finite state machines in terms of awareness and all kinds of fancy stuff. What they didn't realize was that if it's finite, but it also can learn, then the theorem does not apply because it's unbounded. And that's exactly the situation we're in. So it's too bad for Carl Adam Petrie, because this is the kind of thing he wanted to do. He was trying to do. This is what Petrie was trying to do with this Petrie nets. And he got stomped on by that theorem. He didn't give up, but he died in 2010. And as far as I know, he never really was able to get out of this box. So unlike a function composition hierarchy, it's non-reductionistic. And of course, it's obviously non-deterministic. We don't know what order things are going up and down the hierarchy as things happen, and what order things come out in, we don't know. Can't predict that. And as I said, it's non-material. So how does that actually work in the hierarchy? And the key to this is what's called an inner automorphism. There you have it. And you'll notice that we have some sort of operator. It's going to be one of our multivectors here, okay? That's what it's going to be. This guy here, this A, is one of these things here. And this X plus Y is one of these things in the middle, which is a state, as it were. And then here is, we see that if we do, this is a mathematical gizmo, this automorphism. And it has this property that if you multiply this thing inside with A and its inverse, then you'll get the same thing back with a few tweaks. And the cute thing, I realized to use this because I realized that this is the same thing as a Feynman diagram if you unpack. Okay, these are the 2 legs that go into the Feynman diagram. These are the 2 guys on the bar, the horizontal bar of the Feynman diagram. And these are the 2 arrows coming out of the Feynman diagram. So Feynman diagrams, to my view, are just a visual version of this equation. And I just assume that's where he got the idea from, but I've never seen anybody say that. Anyway, what we're going to do is we're going to, as something changes on the boundary, we're going to bubble that change up to the top of the hierarchy. And then when it gets to the top, it's going to bounce off and trickle back down the same way we came up and try to execute and undo that change. So just to show how this is going to work mathematically, how am I doing? I think I got time. Okay, so here's our input. We have A and B, they both change to their minuses, and C and D both change to their minuses. So we had 4 guys, they all flipped at the same time. What's this hierarchy going to do? We're going to do the 1 plus 1 to 2 plus 2 to 4 part of the hierarchy. So A, B, C, D is really the co-boundary of A, B, and C, D, and that's the co-boundary of these guys together. That's the buildup of the hierarchy that we saw before. So as we bubble up, then we multiply on the left. All operations are on the left. So this is the current state of the hierarchy when AB flips. So we want to know what's going to happen next. That's going to be the product of the new thing with where we already are. Likewise for C and D. And that then rotates these guys 90 degrees. You can see this also. We picked up 1 minus sign. So these 2 things got rotated 90 degrees. So we started out this way. Now we're this way. And by the time, and that's going to go up. And then by the time we get down the bottom, it's going to be pointing in the opposite direction. So here we go. We do our co-boundary on these two guys, and that's what we get. Okay. So now the bubble up, then the next bubble is over two vectors, 2D vectors. These guys, I notice this is Tarquinian. Anyway, that's the resulting bubble of these four-way bubbles. We've got two-way bubbles, and they get to the top. And the idea here now is, what do you do when you get to the top? You got to decide, what are you going to do? And the answer is, I'm just going to go with the wave. If the wave's going up, I'm going to put it back down. And so we're just going to float. And so from a wavy point of view, what happens is the wave came in at the boundary and worked its way up, and it hits the top. It's a wall. It just reflects off and comes back out. So that's what we're going to do. Now, instead of integrating, we're going to differentiate. So we differentiate and we get this, because these guys actually don't change, so we still have the minuses. And they drop down another thing. So another level, and we're multiplying on the left again. So our bubble, this is our bubble. Now it's turned into a droplet, and it gets rotated again and trickles further down. And so we have everybody, by the time they've gone up and back down, everybody's gotten inverted. And since these guys are on the sensory boundary, then that will cause the program to actually propagate that change back out into the environment. That means then that before we went from A to minus A, now we're going to go from minus A to, we went from minus A to A, and now we're going to go from I to minus A. Every one of these gets flipped. And so the change in the environment, we've gone with the wave and complemented, the oscillation is completed, and we've maintained our equilibrium. This is just purely space-like computation, okay? And the cute thing with the hierarchy is, because the hierarchy is built out of these exclusionary relationships, we can have 100,000 of these things going on at the same time, and they're not going to get in each other's way. So it reacts, this space-like computation can react to the environment with complete immediacy. Anything that can't happen, it does happen, and only that. Think of a beetle, of an insect. You know, they're running completely in this mode. The fly's eye, the frog's eye. What does the frog eye see? Frog's eye is seeing a space-like computation. And its deepest purpose in computation is to maintain its equilibrium, retain its existence. And if it can, also harvesting some new information. So finally, we're down to the nub here. How does this work? And here you see, here's our impulse. And finally a picture. I appreciate your applause. So we get an impulse in. This is the guy that flips, and assume that's coming up from the bottom. So as soon as he knows I've been flipped, I got to undo this. So he starts asking all his neighbors, I can't undo this, as it turns out in this example. I can't undo this. Can you help me? Okay. And so he sends out what's called a back chain out to, and then somebody, maybe can you help me? And he says, well, I can't do that, but I could do that if this guy could help me do this. And so it works this way. You get these chains going out to people that could possibly help you. We'll see the algebra for this in just a second. Anyway, so when you get an impulse up from the bottom, the first thing that happens is that you get this back chaining started. And it also then bubbles further up. Remember, we went from A and B to AB. So that bubbles up, and the same thing happens here. This guy says, well, I could undo that, but I can't do it by myself. Can this guy? And he sends word out at his level to see if anybody can help him out with this. And that continues all the way up all the way up to the top. When we get to the top, it reflects off the top and starts, and anybody who is on this upcoming path, they're going to get the droplet coming down, the bubble turned into a droplet, and it trickles down. And when that droplet trickling down, it got to meet at a back chain, which says, I'm wanted. And the back chain is saying it's possible. And now we got a guy coming down from the top saying, also, the world allows this to happen. And so it can happen. At least I allow this to happen. By the time, so everybody is waiting for these three things to coincide. And that's sort of the trick in the pattern. The trick in the pattern is you have this kind of hierarchy, and you have this back chaining, and you have these three things that have to be in one place in co-occurrence and in causality is the word. These levels here are causal. These are causal, but in a deterministic and side effecty kind of way. Okay, so I'm gonna rush through. This is how the backchaining works. You can study this in detail, but basically what's gonna happen is Z changed. Z went to minus Z. And so I'm not gonna, okay, and so it bubbled up to this action YZ. So Z bubbled out from below and said, YZ, I have changed Z. Z has changed. What you're gonna do, you gotta change it back to where I was. But the whole point of this action is you can't, this action was defined on the basis of co-exclusion, which says X and Y, Y and Z change together. So I just can't undo Z. I have to do it with Y. That's the way this thing is built. And as it turns out in the example, well, Y, I can't do Y. YZ can't do Y. But he can ask if somebody else can do it. And sure enough, XY says, well, I can do Y if I can do X, I can do Y. Okay? And then it turns out, well, I can't do X here with this guy. WX says, I can do that. Okay? So this is the back chain. And if you look at this, you just rearrange the parentheses and you see what actually we get then is the XX, and we just rearrange the parentheses and these XX and the YY, they square to 1. And so our effective action is WZ. And that's exactly what we wanted. And this can be arbitrarily complicated. This back chaining can give you a tree, give you a loop. You can detect deadlock this way. And but when you start talking loops, you're talking about the level above. It's also got its finger in it. Anyway, if you look at this back chaining sequence, as it's moving along the sequence, you notice you had WX and then XY. So at the time this product is happening, this passing of the baton is happening, these two actions are there at the same time. So we have WX and XY are there at the same time. So we have, in more generic terms, we have a gizmo looks like AB and BC. They have a one thing shared. Turns out this is a unitary element, and it's been identified with the electron. Okay, AB plus BC is an electron for me. It's at level 2, so we identify level 2 spin and therefore magnetism. So for free, we get a physical picture of magnetic field lines emanating out and a current flowing there according to it. And that's completely for free. And this kind of thing happens all the time in this algebra. That's how come I know this is on the money. There's so many freebies like this, you just can't believe. All right, so let's take a little look at the code. How am I doing on time? Now, we'll see. Okay, we're on page 27 of the code. I apologize, I wasn't able to extract this code from the document. So here we have, let's just look down here. What the sensor is going to do is it's going to, the in and out, that refers to this tuple space where our tuples are. So we're going to-
Can you make it larger, please?
I'm sorry?
Can you zoom in, please? We can't read it.
Just working on it here. How's that? That looks good.
Better. Yeah, that's good.
Yeah,
That's good.
yeah. Anyway, up till now, we've been showing in this sensor, we've been showing it was minus. So in other words, the sensor was showing down. And so we pull that in and we say, now we flip it on. Then we wait for that to change and we pull in the plus and put a minus out. So we're just in a loop and we're showing to the rest of the inside of the machine, is this sensor in the minus or the plus position. So that's just what this loop knows. We have an infinite loop, it goes forever, okay? So and virtually all of the threads you see here, they have this kind of structure of it's a forever loop. They always do the same thing, always. So the next one is an effector. This one up here, this is the setup. So actually an effector has two pieces in it. The upper piece is deciding, am I able to do it? Do I have a goal? Is the hand empty and I have to grasp, that kind of thing. But then actually doing it, we wait until we are grounded and there's a goal for us. And if that's true, then we output do it. And then we wait for either the goal or the grounding or the relevance to disappear, not co. So co says, are there, it wakes. This is a synchronizing element that I invented. It says, wait until until all these guys are present, all these sticks, all of these tokens. wait until they're all present at the same time. When they are, then you know you're grounded, you have the goal. This is a detail. And so then you output the command to effect this. And now you're in the outside hardware. Then you do notco. There's another one I invented. That basically says, wait until these guys aren't both there. Well, that means either it worked and our sensor flipped back to where we wanted it, or the goal disappeared. And then if we check out, we read the sensor and it's still there, that means the goal disappeared, but we didn't change the sensor. We don't want to. So we try to retract that. We said, oops, we didn't mean that really. The goal disappeared even though I asked you to do this, so try to undo it. So that's the way the effector works. And the other part of the effector is sending signals up about whether they are there or not. Okay, now we'll go down to, this is the big piece of code. This is the big piece of code that I wrote in 2015. This is the part that's going to do the bubble up here. I'm sorry, these are metasensors. Skip over that. There you go. This is the part that's going to pick up the bubble from down below and decide whether I can do it, in which case I'll send my goals straight down and undo it. But if I can't do it, then I got to bubble it up. And that's what this is about. So I check to see if the stuff from the bottom, I check to see if I got a goal from down below, and I check whether somebody is sending something up to me, and these are still declarations. Okay, here, I'm waiting for something from below, and the sensor from below and the impulse from below, and if it's there and I have a goal, then I'll put out a goal to do it. Otherwise, in other words, I can do it. Otherwise, I can't do it. So I put out a bubble to the top, an impulse for me to bubble up, that's as a bubble, and I start a back chain. So I send out a backlink, see what it looks like. This is a key thing here. Here's me, okay? And this is a tuple here. This is the back chain tuple. And this is just a marker saying this is this kind of tuple. And this is my ID, and this is the ID of anybody else who has me as their other half. So I'm in YZ, I'm looking for a Y. This is the Y part, but I want somebody else to find it, right? So this, and everybody's going to do the backlink is going to put out a tuple like this. And so somebody who's next one up, they're looking for tuples like this to hook into. So everybody at every level is running this piece of code. Everybody at every level is running all this code. This is it. This is all the code that there is, just about, except for housekeeping. The second thread is the backlinking thread. He's looking to see, is there anybody who wants, this would be the Y and the YZ, and this would be the X and the XY, okay? So now I'm looking to add myself to somebody else's problem. And so I'm looking for their problem. This is how I find them. Whatever their problem is, but I'm the other half. And if I get that, then, okay, and if I'm not relevant, I throw it away. But otherwise, then I do the same thing we did before. I try to extend the chain. Here's where I extend the chain. Then I wait for the request for me to disappear. When that disappears, then I pull back my hooks into the back chain. And I do this forever. And then finally, at the top, I bounce off the top. If there's a bubble and I'm the guy on top, well, then I go to undo all this. And I wait for one of those things to disappear, and then I pull that goal away. So this is what happens at the top. And then finally, then where the two meet, thread 3, where we're 3, there it is. So here I'm going to react to the goal now, trickling down from above. If I'm in the backlink chain, then and I'm relevant and there's a goal, then I put a goal down for somebody underneath me. and then I record, this is that, forget that. And then I wait for something to disappear. Either my guy down below disappears, or the bubble disappears, or my relevance disappears, or my goal disappears. Any one of those things falls away, then I pull in my sub goal and I loop forever. And the reason this code looks so shitty is because all these text processors do not have the time for their programmers to do a proper job of formatting code. So you have to battle the word processor to get this stuff out. You notice I have to put these little dots out here so I can put in unformatted spaces. Anyway, finally, the last thing besides those is what I call a corm. A corm is a biological term. It means a root bundle. Like if you want to buy some ferns for your garden, plant some ferns in your garden, you get this thing. It's a bundle of fern roots, and that's called a corm. And that's basically what this is. What I'm going to do is I'm going to, what this guy does is he finds co-exclusions. And that was something in one of the earlier patents. This event window construction, it finds co-exclusions. So I find a co-exclusion. Now I'm going to make a new action. But before I make a new action, I got to do this mod 4 thing. So first I check the grade of those two actions that I found here. They're going to co-exclude. I calculate that grade and I say, if the grade is equal to 4, and either one of them is 1, then I'm going to disallow 3 + 1 actions. And the reason I'm going to disallow 3 + 1 actions in this corm and in general is because this is dark matter. This is the astral trap. This is sequentiality, actually. The odd ones, it turns out, the odd ones are all almost entirely sequential. In other words, you think of electromagnetism, you can do most of electromagnetism with classical mechanics. As long as you're not too picky about what's going on in the details, you can do the whole thing in classical mechanics. And so that's why I'm disallowing these, because you have a potentially extremely intelligent gizmo. You do not want it to have an ego. And so by disallowing this, you disallow ego. That's not saying it can't be destructive, but it'd be destructive in a space-like way. Anyway, I don't allow actions on the odd side of the tree. It turns out this is where our emotionality lies. That's something if you read the other paper, the companion paper here, there's something called the keyhole identity. And that's where this plays in. Anyway, if they have shared nodes, if we have an AB and a BC, then I can't get ABC because I really, that doesn't work. So anyway, if they don't have any shared parents, then I can initiate them on this level. Otherwise, I basically make a new level. If it's a grade 5 or grade 6, then I make a grade 1 and da-da-da. If it's grade 6, it's grade 2, and I make a new action and it with a new grade. And so there we've grown a new action. We've instantiated a new action that we found from that co-exclusion, and we put it in the right spot in the hierarchy. And then finally, we fork off another corm for this new level that we made. So we make a new corm entity for this. Now this is the absolute minimum corm. It just will build any actions that show up on this plate, and it'll just keep growing completely indiscriminately. But that's the whole thing with the code. So going back to the slides, then we're at the end. So we have the same 2 to the 2 to the n exclusive OR structure as the combinatorial hierarchy. The distinction between the indistinguishables in this case is mutual exclusion, this synchronization thing. And since we haven't left anything out, all things are in our combinatorics. The structure here is Cartesian dualism, which is unpopular for a lot of people. But I'm sorry, this is the way it comes out. From our timeline point of view, we live This is where we are psyche. Unless you're a realized yogi, this is where your mental resonance, your ego structure, your sense of awareness lives. Because our normal awareness structure is causal, and this is the causal structure. The space-like is not causal. So we are living in 3+1D. This is where we wound up when we left the Garden of Eden, okay? This is what it's meant when I say now, the knowledge of good and evil. Here's the good and evil part, okay? The good part is, anyway, I won't go into that. The point is that this 3+1D structure is created on the fly. You saw all these Tauquirnians and Quaternions and Tauquinians at multiple levels doing all the rotation stuff on the way up and on the way down, okay? But in the end, it's not until we actually hit the effector and do it out in space that you see something in 3+1D, okay? And so that says that basically 3+1D is being created on the fly and it's feeding back into the waveform, into the wave function. And the reason physicists haven't found, I mean, look at this structure I found. It can't be any simpler. It's 9th grade algebra, my friends, except for the group theory and a little bit of homology theory, you know? It's just not very, it's so sweet, it's so compact, I can't believe it. And the reason the physicists in all their brilliance have not found this because their primary assumption is that 3+1D is primary. And if it isn't in 3+1D, well, it basically isn't there. All we have is probably, oh dear, okay? I'm sorry, this doesn't work that way. It works the way I just showed you. The driver of all this stuff is this hyper exponentially dimensional wave function hierarchy. That's what's running the show. It's the operating system for our ego apps, for the universe's time-like apps. And furthermore, all this change occurs via products with entangling quaternion operators. So as I pointed out in an article almost 10 years ago about the Tauquirnians, what was it I pointed out? It'll come back to me. Anyway, all change is fundamentally space-like. I've argued this. In fact, all things are fundamentally space-like too. Spin and charge and gravity and even matter and love, they're all space-like. And the hierarchy builds up from where we are, maybe 20 levels, down to the quarks, and it's all done the same way. And the conclusion is we are made of space and resonantly entangled with everything. Thank you.
Brilliant, Mike. Thank you very much. I'm sure there are going to be lots of questions. So can I ask you to stop sharing your screen and then we can all look at each other and talk about quaternions. And goodness knows, well, I haven't been the same since Peter Rowlands introduced me to quaternions. So, you know, this is an amazing thing, really. So, questions?
Bravo, Mike.
John Williamson.
Thanks very much for that, Mike. That was really exciting. That was really exciting talk. I'm wondering, you've got this hierarchy you've said of existence, magnetic 2, electric 3, mass and gravity 4.
Yeah.
Have you assigned those, or is there evidence that
it's tight as a drum. There's this theorem that says spin 6 maps to either SO4 or SU3, and so, and I get both of those, and there aren't any others.
Yeah.
So as far as I'm concerned, that's where it comes from.
Okay. So the SO4 you've taken has sort of got A squared equals B squared equals C squared equals D squared equals +1. Is that correct?
It can be either one.
Or you can take -1 as well. A squared equals B squared equals C squared equals.
You can do a plus minus 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 or a minus plus plus plus. Yeah.
But you have done a plus
The
plus
point is
plus.
you have SO4, so you have the 4 orthogonal dimensions. But you can make one of them imaginary if you want, you know.
Okay, but if you do, you're going to lose that plus minus minus plus plus minus minus.
Yes, that's right.
Yeah, it's okay.
Wave function's gone. Yeah,
Okay.
it goes away. There's no evidence in the 3+1 version of where it came from.
No, that's right. That's right.
You have to put the 3D together on your own too.
I've played with some of these things, and I've come to the same conclusion as you have, that all change has to be space-like from a different direction. I'd like to talk to you about that sometime. But very exciting talk. Thanks very much.
Thank you.
Okay. Any other questions?
Got a comment. Hi,
Yeah.
it's Fred Young. Hi, Mike. Nice to
I'm
see you.
looking, but I'm
That
not-
superb talk. It reminds me of things you used to tell me about Topsy. Is that where it all started?
This is it. This is it. Yeah. It all started with co-exclusion. That was about 1989. Or co-occurrence. The coin demo was where this started.
Yeah, I remember the coin demo. Yes. Wow, that's super. So are you commercializing this, or are you?
I'm working on it. I'm trying to find somebody to basically take the peddling, the marketing off my shoulders. I'm too old to be doing this kind of thing, for sure. But the problem is that this is an enormously dangerous technology.
Yeah, I can tell. It sounds
Okay,
like.
and I really am very sensitive to that. And so I can't stop the feds from using the patent, but I can make them pay for it. I can at least knock on the door.
But you can suppress the ego, right? So at least.
Well, yeah,
that'll-
well, look at now, just a second. I just reading a post that I got from Boing Boing about how an AI-driven fighter defeated the best fighter pilot in the Navy in a simulation. They just held a big tournament for AI fighter plane gizmos. All right. So it's not going to be more than 5 or 10 years where the battlefield is completely, the agents on the battlefield are physical incarnations of AIs. Here we're talking standard big data AI. And to think of the trillions of dollars we're pouring down this rat hole for these machines that we construct with great difficulty and ingenuity to destroy each other. Just so we don't destroy each other, which we will wind up doing if we make these machines that can actually have their own identity beyond a space-like identity. See, the thing with space-like identity is it's completely timeless. You're just in the now. So you're not connecting what you did before and so on. You can't, your goal-oriented, is going to be of a completely different character depending on which regime you're operating in. I think it's, and as I say, it's easy to see that the time-like behavior and the causal behavior and the 3D behavior, all these things, they're all in the same category, E8 and so on and so forth. All these things that people, Octonians, they all stink of 3D. And that's why I have no interest in them. And I feel sorry for the people pushing those points of view because they don't go anywhere. You're not going to get out 3+1D until you go to co-occurrence, period.
Right.
And when you go to co-occurrence, then you're in a different world.
Yeah, I remember that coin demo you showed me some years ago, and that was awesome. You know, the kind of the light bulb went off when you you showed me that, and wow, awesome.
Thank you.
Okay, Doug.
Hey, Mike, you know, your comment about space-like states. Of course, anytime we know we have an entangled state, it's space-like because there's not a causal connection between the two components. So the question is, and we also know from Shor's algorithm, the Shor's algorithm takes 2 to the 300th states, you know, which is more than the number of atoms in the known universe. So this notion of space-like states is really important because it says, look, there's an infinity of dimensions out there, hyperdimensional reality that's an infinity of dimensions out there. And somehow, if you're simulating those dimensions versus actually having them is a big distinguishing aspect of it. So, for example, quantum computing, the reason why you get quantum supremacy working because we're actually using actual dimensions instead of simulating those dimensions. Would you care to comment about that?
Well, I watched this quantum computing thing grow from nowhere in the mid 80s to that's what everybody's doing, billions of dollars being thrown at it. And I never quite understood what they were doing. I thought for a long time we were doing the same thing. And I finally realized, no, these people are trying to build a general purpose quantum computer they can write programs for.
Yeah.
I don't see this, I mean, and I'm just say this technology that I'm proposing, it really is not susceptible to the kind of prime number factorization threats. It's got a completely different structure. It's not, you don't do your security using products of large primes. It just doesn't work that way. It's like saying, I'm gonna sabotage a plant with a knife. Well, you can cut the plant off, but you can't infect the plant. You know what I mean? The way you attack these systems I'm talking about is by infecting them. And so this whole thing with primes is there.
Well, the idea,
Anyway, I think those quantum computers are going to wind up as anonymous piles of electronics in anonymous subs in some place, doing things that most people don't care about. That's what
John Williamson.
Mike, I'm very interested. You're looking for a coherence between things that bubble and things that trick. It looks like the trickle down. You're looking for things between the different levels, the coherences between them. I'm interested in how you do that and how you form those structures and how you value judge whether something is a pattern, is part of a wave, or isn't.
Well, that's the co-exclusion thing. That's the homology theorem. That's it just puts this shit together because it can't help doing otherwise. I don't know what else to say.
You're looking for something which is co-exclusion for the whole thing. The whole thing is sitting in some orthogonal space between the two spaces.
No, it's all the bits. All the bits are individual, but they've been combined in such a way that they play together. But at any given point, you're local in the hierarchy.
Right. Okay.
But things that span the hierarchy would be a resonance that's over the whole hierarchy, you know?
Right, so the resonance goes up and down. So you have something which is resonant between it, and
it's
that forms your wave.
But it's not
your wave in that whole system.
Say it again, please.
That coherence is in the whole system. It's resonant between the sides of the system. But when you're going up and when you're going down, you're using a different operator. You're using an operator, a sort of differential operator one way and an integral operator the other one.
Right.
So, but you're looking at those things simultaneously. So you're looking at every level. You're looking up and down, I take it.
Well, I would say as a designer, one is looking at these levels simultaneously. But the beauty of the thing is every individual has no global view at all. Each one of them is operating entirely locally.
Independently,
okay? That was the hard part, you see.
It is
How do you put these things together so they only have to know themselves, and yet they can play together with everybody else?
If you could find a way to use a single operator that went both up and down, instead of doing the up and down separately, do you think that would make things even more coherent?
I don't think so. I don't see it getting simpler than it is.
Yeah, it's pretty damn simple as it is. Beautiful. Beautiful. Very nice. I'm looking forward to reading some more of this stuff. This is the first introduction to this for me, so that's great. Anyway, lovely stuff.
Lou, I think you had a question, and then Peter Rones.
The point about quantum computers is that they would be, if one could merely make them work, rooted in actual physical phenomena. And I think it's helpful to realize that all those higher dimensional spaces are part of the theory. We don't know what the spaces are that are really associated with quantum phenomena. All we know is that certain models use high dimensional spaces. And the whole point is to root that kind of computation in certain phenomena that we call quantum phenomena. And you might well think of adopting quantum phenomena into what you do as well in that sense.
Well, I think as soon as you start looking at things as co-occurrences, then you are looking at things quantum mechanically. It's just that it takes a long time to flesh that out before you realize that that really is. I'm not sure I'm addressing your question.
A plus B is a qubit. A plus B is a qubit. So go ahead, Mike.
Yeah, well, I don't think it turns to qubits. So Doug says it's a qubit, I'm on it.
Well, a qubit is another theoretical idea. What I'm talking about is there really are quantum phenomena. And those are things, you might say a quantum phenomena is something which doesn't get modeled except by quantum theory in the present time. That's a definition of it. I don't know whether there's a quantum world, but there are quantum phenomena. And quantum phenomena may or may not be related to co-occurrence, but you can investigate it. Don't don't make the separation. Look there and see what happens.
I think one thing that comes up here
Yes,
is oh, sorry.
Just a second, I want to talk back to Lou here. At the boundary, which is where you've been living for the last 40 years, 30, 20 years or whenever, I'm just sort of taking a naive cut of what you've been worrying about with such profundity for all these years, okay? I accept the fact there are boundaries. I have voids, I've covered my back, and I'm able to put things together in such a way that they have the same signature as contemporary physical theory. The way you're thinking about things is just too hard for my brain, Lou. I've never really quite understood.
Well, I don't know how I'm thinking about things. All I'm saying is that there are quantum phenomena. That's the experimental level. And people found that they couldn't model them in the usual way. So they made up some new models, which are pretty remarkable. But the engineering side of it is that perhaps sooner or later, quantum phenomena will actually be part of normal computer practice.
Lou,
Yeah,
I think
they're
there's a
going to be the basis for software theory of software systems, and psychology and biology and everything else. Because, I mean, I guess one reason I feel very confident about this is because you can draw your boundary anywhere, make your sensors any sensors you want, and this structure inevitably must arise. So I don't think you've quite gotten me into your question. I wish I could do a better job on it a little bit.
Can I have a go?
I don't understand.
May I have a go on the 3D side for Lou, please? Lou, I think 3D is the key here. And I think the problem with quantum stuff is you're running quantum stuff on something which is complex, which is a planar thing, and it's commutative. But the thing that's threading all of these things is the 3D thread. And the 3D thread is multiple quaternionic, as Peter's saying. And those multiple quaternionic things all fit on one another. And as you go up in the hierarchy, as you jump up, as Mike was just showing, as you jump in the hierarchy, for SU2, SO3, SO4, etc., you keep getting these 3D patterns, which all sit on top of one another.
That's right.
And that 3D-ness is each one of those patterns is non-commutative. And it's exactly what Mike said. The whole thing with E8, all of the division algebras, in other words, and all of the commutative algebras that sit inside those things, I think they're going nowhere, because eventually you end up with something which is, it's just too simple to describe the nature of the kind of thing that you need for exclusion, because you have to have exclusion. The real world is three-dimensional in terms of its appearance and in terms of how we experience it, but also that three-dimensionality is essential for the exclusion principle, for understanding what it is, not that it's just a principle, but it runs through 3D, and that 3D-ness is required. And the fact that quantum computing people, I think they're going nowhere, by the way. I completely agree with you, Mike, there, because I think they're not ready, because the boundaries are important of that. And no matter how complex the inner system is, if you've not included the boundaries in that system, you haven't got a complete self-aware system. But it's the 3D-ness which is important, and the 3D-ness. Sorry, Peter.
So, Peter, your question's next.
Yeah, you say something about 2 to the 6 forms of the Higgs. Could you be more explicit about that? What do you mean by that?
Well, I'm just saying you have in 4 dimensions. We have in the G4 algebra. So you have 4 generators, A, B, C, and D.
Yeah.
And you take those 4 things 2 at a time, you get 6 bivectors.
Yeah.
Okay, so that's 64.
Complete even subalgebra of G4.
Yeah, because I mean 64 it's very important as far as I'm concerned.
It's the 64 forms of what I call the boson, the Higgs boson there, okay? You have 64 different versions of that.
I'm very interested in that because you have 64 elements in the Dirac algebra, and you can map a load of those onto fermions, and then the rest are just space.
It's too quick to go to fermions yet.
No, I'm saying I'm going to fermions because that's what I would do.
Okay. But
I'm interested
the fermions are things like the electron, AB plus AB plus BC, or neutrino A plus, or proton, which is A plus B plus C plus AB plus AC. In other words, there's 3 unitaries in the 4 levels, and they don't come directly. They don't come directly from the Higgs thing.
Can I just ask you about the?
I'll talk about more of that tomorrow, Peter.
Yeah, okay. I'm sorry. Sorry, I can't be there tomorrow, but I'll listen to it afterwards. I have to go for a minor operation tomorrow, but I do want to listen to it. Could I just ask about that again, though? You said 60 squared to a scalar.
16. I think it's 16 and 48. 16 squared to a scalar to ABCD, and the other 48 squared to 0.
Right. Okay. Thank you.
And maybe it may be the other right. If you find it's the other way around, then I've just misremembered.
Okay.
Yeah, that's an
Nicholas,
interesting breakup. 16 and
I'll
48.
cover that tomorrow too. I'll cover that tomorrow.
Nicholas had a hand up, and Christine, you've got a question as well, have you?
I've got one.
Okay, so if we go with Nicola first and then Christine, is that okay? Sorry. So, Nicola.
Okay. Oh, Mike, it's so beautiful.
Thank you.
It's just so beautiful what you do. Anyway, wow. But so, okay, so I mean, so coming back to, yeah, I'll put the specs on because then I can see you clearer. Yeah, so coming back to just our human experience, because you are going into metaphysics with this. What about, so how, I mean, are you talking about life, you know, with birth and death, going out into and then reincarnating, or how do you see this? I mean, does this relate to, I mean, because it's just, I mean, I'm going to have to come back to actually really look at the maths, obviously, but it's just so beautiful. But yeah, go on.
Let me just say this: there's a lot of very old questions hanging around in the fog, and this view blows away an awful lot of fog. There's a lot of low-hanging fruit here in a lot of areas, and it's not. I mean, we're right at the very beginning of a software revolution with this. And just as with contemporary technology, when we first started, it was extremely primitive. Nowadays, we complain if we can't click on an image and put it in our mail right off, you know? So a lot has happened. And the same kind of development is going to happen here. And I think it take 2-3 years before it'll be sufficiently mature to begin doing biological stuff, because the biological stuff is just so hugely complicated. And you know, the first thing I would like to see happen is how do you get from the bottommost tier, where you're doing serious quantum mechanics, to hydrogen and lithium atoms? That stumped me. So that's for the physicists. I'm not doing physics with this thing. You know, I'm happy to hand this off.
Yeah. So I mean, my concern is, you know, obviously, coming from Pythagoras, is, you know, which you touched on, the whole kind of like, well, if you go one way, you can get rid of the ego. So, you know, I mean, I've been thinking about, you know, like I think I mentioned before, like, you know, Philip K. Dick and Asimov, that there are whole kind of moral, ethical questions that like humanity is just kind of like not looking like it's actually approaching at the moment. And there are, you know, the kind of mathematics that I mean, as well with, you know, with Peter, you know, the stuff that is being created, is being envisioned, is so powerful that for me, there is this big question: how do we, you know, you know, I mean, you know, yes, it's safeguarding. I mean, physical health and safety, one thing, but
I'm going to do what I can. I'm going to do what I can. Okay. Yeah. And but obviously, if there are powerful state actors, and you know, the urge to build the perfect AI fighter plane and AI this, that, and the other thing weapon, it's you know, I can't do anything about it. The plus side of this is that it also tells us how to go about saving ourselves, because it can, you know, it's an all-encompassing paradigm that shows us where the love is and where it's not. and how we can begin to try to reorient our entire situation so that we're going in the right direction. And the thing is, once you have this kind of model available, then you can tell where are we now? Well, we're in a purely time-like kind of situation where we are tearing down the space-like part, and they've got everybody, and that's the firewood for what's going on here. We're tearing down nature, that's giving us the energy to continue to tear it down. Okay, so they got everybody carrying wood to the fire. Okay, we got to stop that. That's clear.
Yeah.
And this tells us, this technology can tell us that that is where we are, and the space-like is where we got to go. And most importantly, how do we start moving things? How do we stay on track beyond one political administration? How can we tell if we're going in the right direction?
Okay, Christine's been incredibly patient. So you'll need to unmute, Christine. You need to unmute. Wait a minute. Space bar. It might not work on an iPad. It doesn't have a space bar. So you just need to unmute your sound so that we can hear you. That's it.
Right. Well, yes, I was almost bursting because I'm not sure if this is going to go anywhere or not. But in the light of what you've just said, I think I ought to represent the COVID virus at least somewhere in this discussion, or at least in the whole conference, because I'm not a virologist, but I write, and I'm a writer, and so I'm interested in self-organizing systems that are actually made of language, and so it's a bit like Dino's interest in meta-language and so on. There's all sorts of things there. But I suddenly saw this article by a virologist, and leave aside, you know, all the horrible things about the virus, and just think of it. It said that it works through shifting reading frames. In other words, it's almost like an intelligent, it's neither living nor non-living, as Derrida says, but it's capable, if I read it right, of reading things with simultaneous contradictions. It's also
Christina, are we talking about language now here? That's really the topic, language and its generation? Is that?
But no, we're just talking about a virologist talking about the structure of the COVID virus. And it's a pseudo knot, and it's capable of reading simultaneous contradictions, and it has a slippery chain to it. Yeah. And I don't know why, but all the time you were speaking, I was thinking of this extraordinary system. I've also worked on Paul Valéry and his cahiers, which are written in the old days, where he was trying to make, well, using algebra and stuff. He was partly a mathematician, partly a poet, partly a scientist, and he was trying to model the mind as a system, you know, with phases and structures and shifts and so on. So when you did, I'm sort of scraping the barrel here a bit to relate it to what you said, because it was all very exciting to me, partly by not understanding very much of it. But when you mentioned at one point sleeping and waking, like Valéry would have approached that as thermodynamically as a entropic system, that the sleep state would be more disorderly and having more input, and the waking state would be more orderly and therefore leaves out things. And he was using that model. Well, sociologically, he then used Maxwell's demon as a model to look at
well, I can say that
sociological systems. That's the area that I'm interested in. And I just couldn't resist the virus because no one's mentioned it.
Well, I can say this, Christine, that the process of growth, if you look at the frequencies in the hierarchy, as I go up in the hierarchy, the frequencies are getting lower and lower. And that jibes with the idea of mentation, in that the lower the frequency, the longer the wavelength, and so the longer the view, as it were. So it makes sense from a more macroscopic point of view that the hierarchy, as you go up in the hierarchy, the conceptual heights are lower and lower frequencies. And this occurs because the growth process itself is irreversible, because it's using these tauquirnions and these entanglements. So the growth process is entropic implicitly, and it entangles implicitly. And it's just an amazing concept. It's just totally amazing that the same operators do triple duty in all of this, like a very fine watch.
Yeah, I think your formulation about the entanglements and the space is really a very, very powerful one. I'm going to pilfer it for my novel.
Okay.
I find it highly ironic that we're talking about artificial intelligence. I'm watching the artificial intelligence that's producing Mike Horner's background. Every now and then give him antlers. I don't know if this is just my Zoom, but it's
Yeah, right.
Mike, this is Wolfgang. Can
Yes,
I
sir.
ask a question?
Surely.
I'm pretty new to your model here, so obviously there's enormous, wonderful mathematics that I can see. I'm very intrigued in it, but a few times you just mentioned that one or two of the combinations is, say, equal to the magnetic field, or something that is very real to me, you know, in a sense. I'm a physicist. And I just wondered if you could just to bridge the gap between the abstract and some of these things that we, or at least I know specifically. Can you just run through why, like an A times B and would be a magnetic field? It's so abstract to me that I can't relate at all.
Okay.
You know,
I would say that they're bivectors, and it's the first appearance of spin. The bivectors, AB, they are AB and is minus BA, and so that's the first appearance of spin in the picture, right? We went from 1 to 2, and from going from 1 to 2, we went from the line to the plane, and we went to an orientation instead of a direction, and we got spin. And in my, I guess, a naive mapping from physics, if you pointing in the same direction, then you have a magnetic field. And the other part of this is that when you look at the SU3 part, that maps to level 2 and level 3, AB plus CDE. So you, in the middle of your basic component in the tauquinion is a 2 and a 3, and that is, you're guaranteed that is electromagnetism. And actually, Keith Bowden, an old-time member of AMPA, he, in his thesis from the early 80s, talking about something he called the twisted isomorphism. There, apparently, it is a mathematical fact that when you start just doing this straight homological rise up through the levels, 2 and 3 always turn out to be electromagnetism, is the feeling I get, although I don't know that for a fact. So I don't know if that made the connection for you, but when I see these electrons flowing along these back chains, I see an electron, you know.
well, I mean, you know, you've got an A and a B, and you combine two things. Are there charges there? Or is distance there? Is there any of these other things?
No, just spin.
Then how does it? Well, okay. I'm stuck. I mean, how does it relate to physics?
Well, in a sense, there is no physics in this. It's pure combinatorics.
Comment?
Possible model. It's a
yes,
model.
yes, Lou. And then there's a question from Peter Marser.
Well, Lou wanted to help Wolfgang. Go ahead, Lou. Lou?
Who's up?
Lou.
Oh, okay. I was going to say that one route for making some identification between what you're doing with the Clifford algebra and the physics might be by way of comparing it with Peter's work. because
Yeah.
there you have again identifications of various physical states and particles with elements in Clifford algebras, specific elements in Clifford algebras, quaternions in Clifford algebras. So if we could get a lineup between your choices and Peter's choices, then that would help.
Yes, I agree. That exactly.
That's a homework problem.
Yeah.
Thanks.
I'm sorry, I can't really nail your question, but I guess I come from the school of thought that says if it walks like a duck and it quacks like a duck, then I'm going to take it for a duck until otherwise.
Who are you assigning that to, Peter or Mike?
To Wolfgang.
Okay.
Okay.
Peter,
Got a homework
Master.
problem. I understand.
Peter,
I have a
Master.
second question. If I can.
Right.
put it in.
Wolfgang, can you just let Peter ask his question because he's been waiting a long time now?
Am I coming through, my voice?
Yes, you're fine.
Mike, I'm very much in agreement with your stuff, but didn't you actually tell us something that jives with the results of renormalization group theory that is about new properties of matter, that in fact quantum effects only affect spaces that are mathematically described in up to 4 dimensions.
Yeah, there's only
above that. If you look at effects, as you can, the effects on matter are just purely classical.
That may be. I don't know. I don't know. I don't know anything about real normalization.
Well, I can send you. I can send you something about it, but Ed Wilson actually got the Nobel Prize for this work, and it all seemed to make very sense. I mean, Lou also told us that there aren't any quantum machines, more or less already, but there are some very complex quantum machines, magnetic resonance imaging machines.
Well, I would be more likely to say that a bacterium is a quantum
actually make images using quantum mechanical processes. And they're used all over the world.
I don't know, Peter. All I can say is that the way to understand the organization of complex systems is the way I described, and they produce what appears to be sequential causal behavior when you look at them from a time-like point, from a causal point of view. If you don't look at them from that point of view, then they're not. You know, I think really a cell is a macroscopic quantum system.
Yeah, I agree with you. I'm just trying to see how the pieces all fit together, because it does seem to me that we each bring to this particular quest some piece of the jigsaw, and we want to fit it into a coherent picture whereby the things that we know of best ourselves fit into this coherent picture and complete the picture of the elephant that is in the room, which is the universe itself.
Okay.
Yeah, we're entangled with it.
I think Mike Horner's got a question, but I wonder if I can just ask you a very practical question. What did you write your program in?
It's written in a personal expansion of what was called Linda originally.
Okay.
Linda was if you know what Linda is, and that turned into something called Java Spaces in the hands of whoever was doing Java back then. Okay. And I think it inspired, I mean, we're rewriting it now in Erlang, and I was surprised to find that Erlang automatically, you can just, this associative matching databases, that's now just a standard property. But back when Linda came out, this idea of an associative match was not common. This is mid 80s.
And you said something.
And so Linda was intended, it was called a coordination language. And the idea, it just had in, out, read, and eval for putting tuples in and out of tuple space. And it was intended to be embedded in an existing language like Fortran. So you could have a little bit of coordination there and along with your algorithm. And all I did is I just threw away everything except for the coordination aspect, except for the tuple handling, and then added co and not co and anti-co and things like that. And then sort of just ginned up a syntax for it. And I have to say, my students in Denmark in the 90s, they implemented all this stuff. It was just wonderful. They used the Unix tools to make the compiler. They wrote it in C and so on. And the only thing they did, to my great regret, that was they disobeyed orders. I said, no cowboy code. And they just could not resist. And so we wanted to run fast. And so they misused strings so they could get an 8-bit double word transfer. They had no 0 byte on the end of the string. And sure enough, 3 years down the road, some programmer didn't realize that that's what was going on. And he pulled them all out and replaced them with a legal construction, and the program stopped working.
Okay.
That's the sad
well,
story.
Well, thank you. That's a fascinating talk in itself. Mike Horner.
Mike Manthe, this is Mike Horner, one of the many Mikes. Following on Peter's comment about the renormalization group, I happen to have been fooling around with that. It's initially used looking at the 4 forces of nature, and the equations have a sort of ... then things follow. And there is a nice book which is called Incomplete Nature, and a guy called Deacon, Terence Deacon, has explored the use of the idea from inanimate things to information things to living things and then to sentient things, which precisely corresponds with what you're talking about, and extracted a 5-star rating from Nicola.
Well, thank you.
Wow. Okay, folks. I think we should stop.
Wolf had a second question.
Oh, sorry, Wolfgang.
Yeah, I assume that your program would essentially model me, right? As I'm a complex being, right?
Yes.
And then I assume that if I ran 2, 3, or 4 versions of them, I would start getting a little society and so on. So my question would be, what is the role of the operating system in this configuration? You know, because I could see the universe being described as interacting beings, and I'm wondering what would be the operating system in your scheme?
Well, the hierarchy, or these interacting hierarchies, they're a distributed operating system, you could say. And in between them, you would see, looks like 3+1 messages going back and forth between these entities. If they have unshared tuple spaces, then they have to communicate in 3+1 over wires and stuff like that. And so you would have, as it were, a collective. I think you think of an octopus, right? Those 8 brains and the 8 legs of an octopus, they are connected by nerves. Each one of them is like a cycle hierarchy, like we saw. And then I think then that they achieve an integration along the nerve ending, so that they each have an 8-level gizmo in them, but they're all the same 8-level gizmo. And so they all behave the same. I don't know. And there's another question along those same lines. If this is really so, and this space-like computation is really, truly, as it were, space-like, well then, if I turn it on in the right way, will it levitate? Or will it be, can it, as it were, entangle itself at these macroscopic levels. To me, that's an experimental question. I don't know. I would assume.
Well, I'm more thinking of the fact that the operating system would be at some higher level from any of the individual programs that it's running, and I'm trying to get at what is that fundamental.
I would say there's no operating system, period. Yeah, I mean, the thing running the show is the hierarchy. And at the other side of the hierarchy, and the other side of the boundary, is your sensory boundary. And there you've put all your hardware details. You know, that's where your numbers are. They're on the outside, built into the sensors, so that a sensor shows on when the voltage is 3.5 and not 3.49 and that kind of thing. That's all on the outside. And so you might want to have an operating system of a standard nature like today to keep track of all your devices and make sure the I/O is doing right and all that kind of thing. But it's strictly down in the nanocode, as it were. It has no executive effect whatsoever. The executive effect is in the hierarchy.
I'm going to talk about that in next week's talk too. Simulation and the universe.
Well, Doug, do you want to say something about what you're going to talk about tomorrow?
Yeah, Mike's talk was brilliant. Of course, he's taught me everything I know, and I'm going to go. You know, I'm an engineer, so in fact, I have 3 degrees in electrical engineering, but my PhD was in quantum computing on this subject, and so I look at it. Mike looks at it very mathematically and abstract, and I look at the same stuff very concretely and engineering wise. And so, like even A plus B, you know, it turns out when you go through all the possible states, it's a quantum bit, it's a qubit. And that's what I proved in my dissertation 20 years ago. And so when you start looking at it from that perspective, then you go, well, what does A plus B mean? Even the plus itself means I have simultaneity, which is non-relativistic. So here the math meets the concrete in the sense that what looks like an abstract math has deep meaning in the concrete physicality of it, okay? So I'm going to go into more detail about this concreteness supporting the math that Mike is doing in my tomorrow's talk. And then the following week's talk will go more into the, well, what does this all mean now we have this infrastructure layer, knowing that we have a hyperdimensional space, and what does that all mean? So.
Okay, well, I'm looking forward to that. And thank you everyone for coming this evening. Thank you, Mike, for such a wonderful, stimulating talk. A very multi-dimensional talk, I think, which is probably appropriate.
Yes.
And it's really, really great.
I just want, Wolfgang, if you are so inclined, feel free to email. We can try to discuss this outside.
May I say something? I'm talking on Thursday, and I may change the talk to fit in more with what Mike was just saying. I'll decide whether I've got time to put something together that fits in with that. But the Light is Heavy one is ready. So.
But Light is Heavy is such a brilliant title, John. So you should keep the title and just talk about what you want to.
I will do. Okay.
All right.
It's 5 o'clock BST, yeah? Tomorrow.
Sorry?
And it's 5 o'clock BST tomorrow.
Indeed it is, yes.
Little heavy.
We're in week 3 and we're still here. So there we go. How's that happen? So, all right, well, we'll see you all again tomorrow evening. And thank you for coming. Okay, bye-bye.
Bye-bye. Thank you. Bye-bye.
Good to see you, Mike.
Bye-bye all. Good to see you.